understand our causality analysis engine does our log stitching, we're now going to look at how to analyze a stitched alert. So causality and timeline analysis of alerts and suspicious activity, how we use the causality view inside the causality instance graph, and how we use the timeline view. No questions? Anytime? All right. So in this module, by the end, you'll be able to analyze alerts in the causality view, understand the different node types that we have in the causality graph, the main page, the main portion of the causality view page is called the causality graph. You'll know how to perform actions by using the shortcut menu of a process node. What kind of actions do we have? Add to the allow list, add to the block list, terminate a running process, quarantine a file. You'll know how to navigate over the process tree. Yes, to view the children processes or view the parent processes and hide them. How to obtain the event data for a process node by hovering over it or clicking on it. And how to analyze your alerts using the timeline view, a different logical view, so you can see the timeline of activities that were triggered when the XDR agent generated the alert. All right, so first of all, the causality view. We're going to use a bit of an example for this module, very much the same example you'll follow in this lab, the lab at the end of the module. So here's our case study. A user accidentally finds a VB script they've received from a trusted source. Or they found it on a USB, they did the wrong thing, and they've run the VB script file. And we can look at the script file if you want to, the script that we actually do run, but it will perform some, it'll perform some file operations we're not showing you, and then create two child processes. It's going to run, it's going to start mshta.exe, wait for half a second, then start PowerShell with a command line option we haven't seen. Yeah. And when the user runs that script, they see a prevention alert pop up. So let's emulate that activity, yeah, through the presentation as well. I'm going to do exactly what the user does. This time we'll use a different script. We're finding another script. Don't you do it, you do it for part of the lab. And I found another VBS script. Yeah, it's meant to be there. I'm going to run it. And some things are happening again on my PC. I don't know what's happening. And then there's a prevention alert pop-up. Yeah, so that's actually looks like abnormal activity from a user perspective. And then we see Cortex XDR block malicious activity. The application name is the Windows-based scripting host, wscript.exe. Yeah, and which module provided the prevention, behavioral threat protection module. And here's all the additional details. The user can see by default, we're not hiding the alerts from them. We can if you want to. But at least this way, the user can also then contact someone in help desk. Yeah. So you can see here the details to provide. Can you go and verify if you see the alert in the alerts table? Yeah, and we see, again, a behavioral threat protection module and which rule was matched. A behavioral threat was detected. Combinations of activity that aren't normal. And so we prevented that activity, terminated the process, and when they do contact the IT person at help desk, and they confirm that in the alerts table. So now I'm going to go and refresh my alerts table. I've already got a filter based just on my host name, and there's that new alert, 508 my time, 509 now. Yeah, and here's the alert itself, and we can see a lot of the information in the alert side panel here by scrolling across and seeing the different columns. Yeah, the host name, the username with which the script ran, the severity of the alert, the source of the alert, and the action. Prevented, blocked, not detected, and reported. Yeah, the category was malware. And again, you can click on the alert to see more details, just easier to see without having to scroll across columns. Yeah, general information, the alert ID. Now I know the incident ID, the username, the action. I can collapse a section and expand. Here are the MITRE attack tactics and techniques. The host details. I don't need the host details. Show me process execution details. I collapse that. Yeah, so we have a lot of detail right here just on the alert side panel and by scrolling across. Yeah, but really to get the details of what happened when we ran the script, we need to use the causality view. Yeah, And I'll do that afterwards, but I'm just going to make sure it has been stitched by Cortex XDR. So we see a CGO name, it's already been stitched. This will be a detailed alert with log data stitched. So we'll continue with that very soon, yeah? So that's what the user saw. A behavioral threat was detected. Any details they want to see. If they closed it too quickly, we can see the events from the XDR agent console as a user. All right. So in terms of investigation, here we are as the SOC analyst, and we saw exactly the same alert come through, or what was matching the prevention alert pop-up. We see the alert source is XDR agent, malware category, the action performed, prevented and blocked by the agent, behavioral threat, as we saw, yeah? We can even identify straight away this is a stitched alert. We have a CGO name, and the root cause of the attack is wscript.exe. Doesn't mean it's malware, but it ran the script. So it's the root cause. So the question for us as an analyst is, what other details do we need besides what we see in the different columns or clicking on the alert itself? We need to have a complete identification of the attack. We need to understand the timelines involved, when the different activities happened. We need to also understand what kind of damage resulted in running that script. Has there been any persistence of any malware on the endpoint? Is it now propagating within our environment? We may need to even perform remediation. So consider different remediation possibilities. So from a perspective of an investigator, we need to understand which processes were involved in the attack. We need to understand the parent and child relations of the causality instance that caused the attack. We also need to understand which were the process file names. What were their paths? What were the command line arguments used when PowerShell started, when regedit started? We also may want to utilize the verdicts from different threat intelligence sources, not just from Wildfire, maybe from Autofocus, from VirusTotal. We also need to understand what were the resources impacted. The user saw weird behavior on their workstation or server, yeah, and then the pop-up, but we need to understand what file activities occurred, which files were created, deleted, changed, or closed, yeah? What file system attributes were changed, what Windows registry keys were modified, created, deleted, yeah, changing the way your operating system, your applications behave. What network connections were established, maybe a command and control connection outbound. And we also need to understand if a combination of these activities happened, when did it happen? In what event order? What's the event timeline for the period of the identified activities? So what we do, once we identify the alert in the alert table, we find it in the incident. Again, just a brief review of this part to start off with. If we see an alert, even if the alert source is not XDR agent, as long as there is a CGO name, yeah, often no signer, but a causality group owner name, this is a stitched alert. These are non-stitched alerts. It's possible that the stitching can happen if this is an alert from a pro agent, but maybe our causality analysis has not yet done the stitching. And if you refresh the page, you'd then see the CGO. So that's possible for a fresh alert, yeah? But in this case, this is stitched. These two are non-stitched. Also, we see to the left of the alerts, a green dot or a gray dot. Green dot indicates that when you do a right click, we have the option to open card. You can use a new tab. I prefer a new tab, or in the same tab you're using now. So that's all green dot means. You have the option to open card. If we have an alert and there's just a gray dot and there's no CGO on this one, it's non-stitched and there's no open card. Yeah. So we have no causality view. For a non-stitched alert, we have a limited causality view. For a stitched alert, we have a full causality view. Let me remind you, as we looked at earlier on, here was a non-stitched alert of when I ran a script. Yeah, I've got a causality view, but not so much detail in it. I can't see, did WScript start any child processes? Can't interact with them. And here's the stitched alert for exactly the same activity. Forget about Explorer there, yeah? But now we can see all the different parent and child relationships between the processes in this causality instance, and what each of them did when we click on each of the different process nodes. Yeah, when we look at the event detail, the action details down the bottom, MSHTA performed 4 registry actions and 41 module actions. And we can analyze what it did. All right, so again, for a non-stitched alert, you can do open card, but it's limited information. For a stitched alert, full causality view. Okay. If you have questions, you're welcome to ask, yeah? So why I've done a couple of demonstrations, now you can picture all of this. We've seen our causality view layout. We have the title bar up the top, where you see details like your endpoint name, its connection status, its MAC address, its IP address, the causality group owner name and its process ID. We then see the graph that you can plus and minus, view children, show parents. You can interact with the nodes on the graph. And the node that you click on in the graph, you then see that node's attributes in the dark third section. I actually think it's dark blue, but it is. This slide is black, but you tell me, is that dark blue or is that black? That's really dark blue to me. Anyway, you get the idea. Here's the title bar. Here's the graph itself. Here's our node attributes. Which node attributes? If I select the alert node, I see alert attributes. There are 3 alerts. Here's alert 1 of 3, 2 of 3, 3 of 3, all the alert details, and in table format if we need them. If I click on a process node, we see the process node's attributes and the process node's event tables. What did WScript.exe do? Different from what reg.exe did. Yeah, so again, the graph, the selected node attributes, reg.exe's details, here's its SHA-256, MD5 hash, its wildfire score, ability to download the report. Yeah, copy the hashes if you wanted. Here's the path to it, hover, username with which the permissions ran. We can see that from here as well. And again, all the actions performed by the selected process node. So that's just the structure of the causality view layout. And here's an example in the slide. Our title bar, host name, we see the connection status. Green dot means connected. See that as well with connected. MAC IP, the CGO name, and the process ID it was running with when it was running. Again, the causality graph itself. And you can interact. You can right-click on a node. You can right-click and interact with them to control them. The selected node's attributes and the node event table down the bottom. So the first thing we see again, I won't overdo this. I think you've got the idea. In the title bar, a summary of the endpoint and the CGO process. What is the root cause of this alert? The process ID, MAC address IP, pretty straightforward. There are actions that we can perform from the causality graph as well. So a series of actions are provided. We'll cover remediation suggestions later, but if I needed to do further investigation, we might need to do further investigation, right? Yes, some of you may have identified already when the script ran, WScript.exe, started 3 different processes. We see the 3 process actions. Yep, the first process it started down the bottom was process execution of reg.exe, then MSHTA, then PowerShell. I don't know when did the file actions happen first? Or probably not, but anyway. So we're not showing it to you in a timeline here. I'm showing you the file actions in a chronological view as well, from the oldest action to the newest action. And these are the 10 file actions, again, performed by WScript.exe. All right, a file read of Verloc VBS first. That makes sense. We ran the script. Here's the path to it. And then a file read again, file delete. Oh, we didn't know that before. I showed you before, yeah? of a virus5.vbs in the hidden app data directory for my student, and then a file create of that file in the hidden app data directory, and then a write to it. And just in case it's there, we'll try to delete the old virus5.exe in the student home directory, because we're about to create a new virus5.exe and write to it. Yeah, so these are the actions identified through the EED log that the agent sent when it sent the alert. Yeah, these were the 10 file actions. And here were the module actions performed by WScript, some DLL loads. Yeah, loaded a whole number of DLLs. Where do they come from? So module actions. And again, when we look at the all actions, we're seeing a sum 43 plus 10 plus 3 equals 56. And here's the 3 alerts in the alert table view I showed you before as well. So remember, we might need to go and do further investigation, right? We might need to actually live terminal and go and find, is there really that, what file did we notice? Maybe there's actually a virus in my home directory, for example, yeah? On my server, on my workstation. Maybe there's a virus5.exe sitting there in my user student, yeah? So we could take an action, for example, and live terminal. Straight away, this is the affected endpoint. We live terminal to it. We could use the File Explorer and then do some further investigation through the File Explorer and dig down, find the users folder, my home directory student. Oh, and there we go. Yeah, virus5.exe. And there's the date timestamp for it as well. And from here, I have other further investigate or actions I could take as well for that file. Does the user see it, by the way? Does the user see the file in their home directory? A normal user won't have the option turned on like I do to view hidden items, yeah? So if we go and check the home directory again, as the user, we don't find it. It's hidden, yeah? Okay. And there something else from something else. Further investigation required. Is this malware now propagating internally as well? Are there other affected hosts? Have any hosts actually done process executions of these files? Yeah, so this is our starting point for further investigation. All right, so that's just our title bar to start off with. Some of the other actions. We'll cover remediation suggestions. We'll look at the asset view. When we cover module 7, we've learned about endpoint isolation and how to control the allow list for network isolation as well in the agent settings profile. And what we show you, of course, in the graph pane is our causality instance graph, the causally related processes, the components that are related within the attack, and there are different node types. Yeah, and we have different colors for the nodes as well, and sometimes different statuses to indicate this is in the block list, for example. Yeah, we've placed this file by hash in the block list. Yeah, there are 2 alerts that have been caused by matches on this process. So we can identify different types of process nodes, and through colors like blue, it's a benign process. If there's a malware verdict, we'll show you the process or file as is red as well. So the nodes are causally connected in a tree structure. There are different, again, node types. We're seeing here just process nodes and an alert node. But we also have user nodes, IP address nodes, and we show you an icon to represent whether code injection, and there's also an icon to show you whether an RPC call has been used for a process. So special icons. And parent-child relationships with the leftmost node is the ancestor. This is the parent of this process, which is the parent of this process. The selected node or it could be a process node or an alert node. The node you've selected in the graph, we then show you that node's attributes in the dark blue. It is dark blue. That's black, that's dark blue. No one agrees with me? You do, hopefully. Everyone sees color different, I know. Okay. So we don't see the graph, but which node do they select? Yeah, straight away you can see from here, right? the wscript.exe, and we can see the command line with which it ran. We see the process ID, its parent process ID. The wildfire score for wscript.exe. Its hashes, MD5 and SHA-256, the username with which the privileges ran, the process ran, and the full path to it. So this is the path to the CG, well, to the process, and this is the command line with which it ran. And then we have down the bottom, the selected nodes event table. By selecting the process node over here, wscript.exe, we see what actions were performed by wscript. If we click on PowerShell, what were the actions performed by PowerShell? I think you got the idea. If you have questions, you're welcome to ask. Yeah, if this is the first time you're seeing the deep dive on performing causality analysis of a stitched alert, you may have many questions, so you're welcome to ask anytime. I sometimes demonstrate this as the first thing on day 2 of the class. So if you want a brief demonstration or overview or review of this, we have time for that tomorrow morning too. All right, so let's focus a little bit more on the causality instance graph. That's what you interact with a lot. And here we're showing you the legend for our process nodes. So here we're seeing a process node, and we're showing you the process name and an icon to indicate that the process is still running. Sometimes we don't get this right. Maybe the process has been terminated since we stitched this alert. So this is not always correct. Yeah. But anyway, that's to show the process is running. We will identify a process, the causality instance ancestor, as the causality group owner. It owns the causality group. We're showing you in this case, we have 4 children, 4 child nodes. We're also seeing and this is a Win logon is not running with my user permissions. It's running under NT authority system privileges. So the authority the process runs with might be domain name / username for wscript.exe. Yeah. Right. And we also show you in terms of the legend, again, a malware process is color-coded red. If you click on it, it's now solid red as well, but it was always red when it was identified as malware. If you right-click and add to the block list, or it's in the block list already, you'll find the cancel icon on it. So we've found a malware process node. The verdict is malware. We click on it, it turns solid red. And then we maybe right-click and say add to the block list. Okay. So from a process node, if you right-click, what can we do? We can see graphically from here there is one child process created by mshta.exe, which is a normal Windows process, but why was it called and which child did it start? So we can view children, hide the branch. So actions to navigate through the process tree. We have a series of actions for attack response. Again, do we need to add this to the block list or add it to the allow list? If there was a malware verdict, which we deem to be incorrect, yeah, we need to allow the process to run on all of our endpoints. Be careful. You could right click and add to the allow list. Yeah. So add to the allow list, add to the block list. If auto quarantining was not enabled on the agent malware profile, remember we can turn on automatic quarantining, but if it wasn't, we can then initiate a quarantine action instead of going to the action center and having to do it through the action center form, do it this way. Again, we'll talk about remediation suggestions tomorrow. It's fantastic. And we can search for the file on all endpoints, but if we have the host insights add-on, and because this process is not identified as running, we don't have the option to terminate. It's grayed out. Some options for further investigation. Search for it in Quick Launcher, use the hash view, which you used in the last lab, or open it in VirusTotal. See the VirusTotal verdict. All right, so when we opened our causality graph, we didn't yet. Let's have a look. Remember I ran that new script that we hadn't run before? I saw the prevention alert pop up, you might remember. The last alert was triggered by wscript.exe, another behavioral threat. And we've got all the details down here as well from the user perspective. Yeah. So let's go and find that alert. I said we will then open it up using the causality graph. So investigate causality chain. Is it stitched? Yes, it is. You've got the open timeline, but I'm going to use open card. And so what do we show you? We're not going to show you the hundreds of processes running on that Windows server. We're showing you the attack region, the processes involved in the attack, where behavioral threats were detected. So we're showing you the causality group owner is wscript.exe, and graphically, it started 2 child processes. It doesn't look like they're still running. We don't have that icon, arrows. Yeah. And again, the ability to interact with each process node or alert node. Yeah. And there are different alert node icons. This is the alert node icon for an XDR IOC, not XDR agent. Yeah. There are different alert node icons, but there are 3 alerts altogether that we could analyze from here. Yeah. So remember, we're not showing you where did wscript.exe get launched from. Was it started from cmd.exe? Was it started from Explorer? We're just showing you the attack region, the processes involved in the attack that were terminated, yeah, by the agent. We terminated PowerShell. We terminated wscript. mshta.exe is a normal Windows process. So these were the processes that were terminated. MSHTA called for 1 child process. Let's view the children. What process call did it make? And there is and this is a server still running, the local security authority subsystem, and MSHTA used an RPC call, a remote procedure call. You see this icon? This is an RPC icon. So remote procedure call was made to this process. What did this process do? We'll click on that process node, which we can see is still running. And then we see the actions performed by, well, maybe many of them not related to our attack, network connections, system calls, but this provides a wealth of information for further analysis. Maybe we will see some weird IP addresses and ports we're opening up connections to. I have to scroll all the way down. Otherwise, I can't find the scroll bar on the bottom. Yeah, to find the scroll bar on the bottom, you have to go all the way to the bottom of the list. And then we're finding different network connections from source IP, source port, different authorities to this destination IP. What destination? Is that one of our IPs? Yeah, .25, it's our domain controller. Yeah, don't know what that port is, but we get a lot of information straight from a stitched alert, yeah? Again, imagine you're finding command and control connections to servers on the internet. So by default, we're not expanding everything for you. We're showing you just the attack region. You've got the option of right-click, show parent, then show its parent if you wanted to as well. And as I showed you, if there is a child process, 1, 2, 3, you'd like to view them, right-click and view children. So we have different alert node icons. That's what I was trying to find for you. This is the shield icon. That's our Cortex XDR agent alert. And then there were 3 BIOC alerts generated by Cortex XDR. So this is the BIOC alert icon, alert node icon. If you hover over a process node again, we show you that process information. So you don't need to look in the dark blue details just beneath. Yeah, so the path, the command line, the hash, the authority, signature, wildfire verdict, and the running time. Is that this process is still running. Because we've got the analytics engine enabled, one of our analytics detectors has built up profiles of, we've identified this same executable on 36 endpoints. It's got this hash on 11 of them, which must mean that it has a different hash on 25 endpoints, right? We're matching exactly the same hash on 11 endpoints only, so the same file name must have a different hash on 25 others, yeah? Why does that happen? Well, Windows 10 is different from Windows 11. Windows 2016 server is different from 2019 server, the binaries. Even with Windows updates, they can change. So don't panic with things like that. but it has executed from the same path. We know this is benign. We see, well, we know it's benign, but we see it's blue as well. Wildfire's worked out. Yeah, that's the real version, not part of a rootkit. All right, so again, we have different alert node types to review. The XDR agent alert node, no number, there's one alert. Where wscript.exe is the CGO. If we look at Explorer, and above Explorer here in this example, there are 6 BIOC alerts. Behavioral IOCs, rules that Palo Alto Networks provide to our Cortex XDR, and custom BIOC rules that you can add as well. And if the XDR matches data when it receives log activity from our agents, our pro agents, that matches those behavioral rules, behaviors that we don't want to see, then it's Cortex XDR that generates the alert. Yeah, not the agent. All right, so alert nodes, you don't have right click. It's right click on a process node, not the alert node, but you can click on them. And if I want to see those 6 different BIOC alerts, you know how with a, yeah, I showed you. We also have other node types as well. So here we see a user node. And if you click on a user node, I can see a logical, user on PC20 and the services that are running. But with a user node, if you hover over it, we then have user information. Some of this information we don't get by default. Yeah, I can see the username. We know the logged on username. We know the domain name as well. But by default, we can't obtain other Active Directory attributes without enabling a Cloud Identity Engine instance. Yeah, some of you may remember from yesterday afternoon. I hope you remember from yesterday. But if you need to integrate XDR with your Active Directory, we need to activate a Cloud Identity Engine instance for free. And then we need to configure our on-prem CIE agents that communicate with our domain controllers and send these types of attributes to Cortex XDR for additional analytics information as well. So user information, analytics profiles. Galadriel here has authenticated 600 times in the last 30 days. Yeah. It's about 20 times a day, right? Is that normal? I don't know. 20 times 30. Oh, no, that's too much. Oh, no, I'm right. Yeah, 20 times 30. So is that normal user activity to authenticate 20 times a day in the last 30 days? Again, we have analytics profiles that might give you insights that you may need. Also in the causality graph, I showed you when I expanded one of my processes, we saw that it had used a remote procedure call. We see an RPC, used a remote procedure call to ask this service to run a procedure, a remote procedure. This is not the injection icon. No, it's not. The injection icon looks like a injection. Yeah, you'll have to use my imagination, but it will show you a bit like a syringe. Yeah, we've all had too much experience with syringes, but here's my syringe. Yeah, and you'll see a syringe. You'll see code injection. Yeah. This is the RPC icon, remote procedure call, and a syringe represents code injection. Oops. Please excuse my writing with a mouse, yeah? Okay. And the last view that we provide you is called the timeline view for a stitched alert as well. Only Stitched provides the open timeline options. And what we're doing with the timeline view is now we're seeing a graphic which represents, we understand so many things happen now when we ran that script, when a malware executable began to run, yeah? But we need to understand the relationship of when did each action happen? When did the process actions happen? When did the file actions happen? When did XDR generate an alert, the agent? When did XDR create the BIOC alert? We need to see things graphically in a timeline. And that's the timeline view. The default time scale is 60 seconds. So we see here a 60-second window. Yeah, that's from 17:43:20, 17:44:20 over here. Yeah, it's from 10. So it's 60 seconds worth. If you want to see the time scale over an hour, 1 day, 7 days, 1 month. That's about it. We only store your detailed, well, actually, no, I shouldn't say that. But yeah, it can choose your time scale. What we show you are, again, the process information. And then we have different event categories that are being identified and event nodes in the graph in the middle. And then we correlate when the event type actually happened. Yeah. And these are clickable as well. You can select one of these nodes and it then opens up the details down the bottom. So the idea is when we opened up our timeline view, we're now seeing graphically within this 1 minute, yeah, at exactly this second, this is when the first process execution happened. And we can then look at the details of which process executed down the bottom if I click on it. And then another process execution. So maybe this was wscript.exe and then PowerShell and then regedit.exe, yeah? We're not sure until we look at the details. But we're seeing the process executions in order. After the second process execution, there was then a discovery event categorized. After the third process execution, there was an evasion category identified, and then we have the XDR agent alert. So again, there can be many more actions performed, yeah? File actions, network connections, and this just shows us the timeline, the relationship of those actions, and when Cortex XDR identifies different event categories based on those process executions and what they did. You can change your timescale by clicking on show me a 24-hour view, or you can choose the slider over here to be very specific. Yeah, let's just narrow in between this time and that time. You can just change your sliders, scroll the time window forward or back. And so what we show you is a legend on the left-hand side, a list of high-level categories of the events recorded during the attack. Up the top is where we'll find the alerts generated by XDR agent. In the middle, we'll find alerts created by other sources, BIOC, IOC, XDR analytics, different categories will be identified. In this case, only evasion and discovery with a tactics that were identified. And then we see the activities classified by type. Process executions, yeah, network connections and others. So we correlate all those actions with the time when it happened. So we have 3 process executions again, a low severity alert, probably an XDR IOC or BIOC, followed by a red severity evasion alert, followed by the actual alert from the XDR agent. And bear in mind that XDR doesn't know any of this activity happened until the agent sent its alert with its log. Yeah, until the agent sends the alert and the log, XDR knows nothing, right? So really we have to wait for the XDR agent to send its alert with the log so we could do the stitching, so we can then show you this timeline of activities and based on the executions that happened, why Cortex XDR generates the low severity alert or high severity alert, yeah, and the agent's alert. I hope that helps put in perspective. So colors are color-coded for severity as well. And for the selected node, I select one of those process executions, the second one here. We then see what was the process execution. Yeah, so wscript started with this command line. It was initiated by cmd.exe. Someone ran the script from a command prompt, not from Explorer. And then process reg.exe started with this command line, and it was initiated by wscript.exe. So again, they're each selectable. So I'm going to give you plenty of time for this lab as well. I want you to do some detail. I haven't shown you everything there is to find. So I'd like you to do this lab. It's a very important lab. It's really one of the main takeaways from this class. What is the benefit of enhanced stitched alerts, yeah? From a pro agent. We want your customers to run pro. It provides a higher level of protection and more detail for us to analyze for investigation, for remediation purposes as well. So by the end of the module, you know how to use our causality view. You can describe different node types in a causality graph alert node, process node, user node. You know how to perform actions from a shortcut of a process node, the right-click options. You can view children, show parents, navigate over the process tree, obtain the event data for a process node, and can also analyze alerts in the timeline view. And you'll be much better at doing that if you do this lab. It's a very, very good lab. I didn't demonstrate everything. So I now will give you lab time plus afternoon tea coffee time. Yeah. But I'm going to keep an eye on the lab activity. I'm thinking we're going to move on. I'll let you know now. We'll probably move on in about 1 hour. I'm going to give you plenty of time for this lab plus coffee, tea. If you complete your break first and then lab before, let me know. It helps everyone if you send through done in the chat. If you have questions, you're welcome to ask. Otherwise, I'll be quiet for you. I'll put a little update on the slide so everyone knows, in case some people walked away, that we are now spending afternoon tea plus lab time. Yeah, short break plus lab time until 3:45 p.m. That's very fair. Sound good? Anyone still there? I'm sure someone is still there. Yeah, thank you, Kent. Real reliable, Kent. Thank you, Tom. Good. Okay. Yeah. Okay. So I'll leave you to it. We got the game plan. Short break, lab time till 3:45. That's about an hour. Plenty of time. Call me if you need help anytime. Okay. All right, everyone. We're going to be starting the last module for the day. It's a short one, but very interesting on the advanced response actions. Yeah. So a short module, one more short lab. Yeah. And that'll be it for the day. All right. See you soon. All right, everyone, we have one last module, advanced response actions. If you're still doing lab, you can pause and continue lab after. This is quite a short presentation, so you'll still have some lab time. If you want to complete the labs this afternoon, you have after hours access in your own time. We understand some of you are busy with other work commitments. Yeah, so the lab access is 24 hours. Any questions about the last lab, you're welcome to call now or through the chat. Otherwise, we'll go through the advanced response actions module available with our Cortex Pro license. We have the remediation suggestions. I promised you would talk about them and what that can do. We have options for auto remediation for some things. Some things we have to manually remediate. We'll go through remote script execution, how we run Python scripts, the different methods we can use to run a Python script on your agent, and how to enable the Cortex XDR EDL service. So that if your organization or your customers use Palo Alto Networks next generation firewalls or Prisma Access, they can retrieve a list of bad IP addresses and bad domain names from Cortex XDR to protect the networks behind those firewalls, to block outbound access to those addresses or inbound access from those addresses, to extend protection to the rest of our network. Yeah. So by the end of this module, you'll be able to perform the remediation suggestions action. There are a few different places to find it. You'll be able to upload your own custom Python script. We have some out-of-the-box scripts provided by Palo Alto Networks. But if you need to run your own scripts, we have to upload them to Cortex XDR. And we'll then go through how you run it on your targeted endpoints and how we track the status through the Action Center. We'll know how to configure and activate the EDL service. Very simple to activate it. It's a one-time job. And then how we manage the entries on the external dynamic list, those bad IP addresses and bad domain names we want our firewalls to block access to by retrieving that EDL list from Cortex XDR. Maybe every 5 minutes, every half an hour, they can be configured to pull the EDL, retrieve it. All right, so the first thing we'll go through is remediation suggestions. This is very much a continuation of the last module. Yeah, we just did some causality analysis of a stitched alert, and we saw a number of problems. We discovered the presence of some files we didn't know before, for example, changes to the registry. So we have the ability within Cortex XDR with the Pro license to provide you as one of our advanced responses with remediation suggestions. So we have to have either the Pro license or cloud licenses, cloud per host. If you only have the prevent license, you will not be able to use the remediation suggestions or other advanced responses. Right, we also have, in terms of authorization, roles that have specific permissions. So if you need to be able to run a script, there are some scripts which you can mark as a high-risk script, and that requires escalated privileges. We also, in order to provide the remediation suggestions, we have to know what was there on the agent before we ran the malware or we ran that malicious script. So we know what happened afterwards to provide you the remediation suggestion. So that requires that we're sending enhanced endpoint data. And it's only available for Windows. So what are the different ways we provide remediation suggestions? First of all, then I'll demonstrate. Here we are in our causality graph. We're seeing the process node. We identified some actions performed by that process. By looking at the details down below, we can right-click on the process node and then ask Cortex XDR to provide a list of remediation suggestions. Or at the top right of the causality graph, we have the actions button, remediation suggestions. I'll tell you the difference between each one. I'll demonstrate. And we also have the 3-dot menu of an incident to ask for remediation suggestions for all of the alerts in this one incident. So it's a much broader scope. And the kind of things we can do with remediation suggestions is even revert a file or registry changes, delete a file. So let me show you a couple of those methods. Good. I still got my alert. That was my live terminal session. Gone. Good. That's not my alert. That's the alerts table. Here, what does this look like? A stitched or non-stitched alert? This is non-stitched, not the one I want to find. So but you could still, from here, interesting. No remediation suggestions on a non-stitched alert, and not from here either. Whereas we take our stitched alert, this one, yeah. And then if we choose, for example, wscript.exe, remember the types of actions we saw performed by wscript.exe. For example, 8 different file actions, just briefly, to remind you what kind of things it did when it ran. Yeah, some file creates and writes to those files. Yeah, we can recognize funny.exe, verloc copy.vbs in the app roaming data, the app data roaming directory. Yeah. So even though we've done our own investigation to start off with, I'm going to go back up here. If I select that process node and then remediation suggestions, it will calculate the suggestions based on this alert for that process. Very good. Here are 2 different suggestions. wscript.exe created this file in the app data roaming directory. If I hover over it, verloc copy.vbs. If I scroll across, endpoint name, and then the suggested remediation is to delete the file. And that's what the description would do, delete that file by path. Yeah. So do I now have to live terminal or connect to the endpoint? This option here provides me with an auto remediate capability. Yeah. So remember, we found the presence of funny.exe, same thing. It's found also another remediation suggestion that wscript created that file, funny.exe. Let's go and delete the file. Yeah. Remediate. We can take all the suggestions if you wanted to and remediate. I won't right now. Yeah. I won't right now, but it would actually delete those files. So very powerful feature. But the difference is here, and I'm just going to jump out of the suggestions. I selected wscript.exe. Yeah. PowerShell did other things. PowerShell performed other actions. And what I didn't show you, hopefully you did your lab. We can see the command line with which PowerShell ran. Yeah. And I don't understand, that's obfuscated code. Yeah. And here we have from the option, let's try to de-obfuscate that code. And now we've translated it to ASCII. Yeah. So sometimes we can de-obfuscate as well. That's another very powerful feature that I just wanted to show you. But PowerShell did different things. Yeah. No addition. MSHTA, there were different actions for registry actions performed by mshta.exe. All of the actions are 4, and here are the same 4 registry actions. And the oldest one at the bottom, it's set a registry value. Here was the registry key name. That's the value name. That's the data it set. What was the registry key's previous value? We don't know. We didn't back up your registry for you, but we know it got changed. Yeah. So now if I select on that process node, remediation suggestions, it will be remediation suggestions that relate to the registry changes. Right. And there we see MSHTA modified. Those 4 different registry keys, the values have changed. However, we cannot remediate it for you. We're telling you, we don't suggested remediation. We could not find the previous value. Yeah. You have to manually restore the registry key. It's a manual remediation, no remediate option. So how do I do that? Is that one of my critical servers and I do backups every night, for example? Yeah. Have we taken a snapshot of the virtual machine that I can restore to? So by running Cortex XDR agent, it still, doesn't absolve you of your best practice requirements in terms of data, disaster recovery and backups and that kind of thing. Yeah. Maybe for some situations, if a workstation was, if there's a lot of malware found on a workstation, a lot of organizations will just re-image the workstation, right? Yeah, disconnect it from the network, hand it to the IT guys and re-image it with the SOE. Yeah, so sometimes we need to perform manual remediations. All right, so that's the difference by selecting each process node for the suggestions. You get the suggestion for that process. So then I'm within this one stitched alert, And then from the actions menu, I ask for remediation suggestions for all the related processes. Yeah, and that's what it'll show us. So it's now calculating the suggestions in progress. They're based on the events initiated by the processes included within this causality chain. So now we see a sum of those suggestions. Yeah, the file deletes, we can auto remediate. The registry, you have to manually remediate in this example. All right, so hopefully that explains the difference between doing the suggestion from a node perspective or from the entire alert perspective. Any questions? If we go to an incident, which incident? Yeah. If we go to an incident, a busy incident, this changes have been made. Very good. Let's refresh. Now we have 463 alerts in this one incident. Yeah. All right. So if we look at an incident, and I'm not going to go and do the causality analysis of my 463 alerts right now. Yeah. But if you did use the 3 dot on the incident, interesting. Interesting. It's not giving it to us. It's not giving it to us. You'll find for some incidents we will. For some incidents we won't. I'll take a different incident. This one's only got 2 alerts, not very exciting. But if I try the 3 dot here, as you can see, we do provide remediation suggestions within an incident as well. I'll try and find a busier incident, one that has more than 2 alerts. This one's got 59, used to be high severity. Someone changed it to medium, we can recognize, assigned it a incident name. We've got a score that's been manually overridden. We can see the overlap. It's now at 77. So manual scoring is higher priority than our rule-based scoring. If there's no manual or rule-based score, we use automatic smart scoring. Yeah, just to refresh your memories as well. What I'm trying to show you here is though we have, 59 alerts in this one. And if I try remediation suggestions, it'll take a little bit more time for the number crunching. No results found. Okay, interesting. Yeah. Maybe that one's a bit old. Cancel that one. Try one more. Yeah, 7 alerts. We'll try that one. I'm not sure what the reason is why some incidents show us remediation. I'd love to find that out. That's a question for Palo Alto Networks. Absolutely. Why do some incidents provide remediation suggestions and others don't? But the idea again is we're doing it for all of the alerts within the incident. So you can see an example. All right. So 3 different methods, yeah? From a process node for its remediation suggestions, from the alert in the causality view for all that alert's remediation suggestions, or from the perspective of an incident. I think you've got that. So when the remediation suggestions calculation completes, we then see the available suggestions. If it is something we can auto remediate, in this case, CMD.exe started a causality chain that's still running, and the remediation suggestion is to terminate. So right click and remediate, and it then initiates that action, which we can track in the action center. So here are the types of suggested remediations we can show you: delete, restore, or rename a file. We saw delete file. Delete or restore a registry value. We saw restore with a manual remediation requirement. Terminate causality and manual remediation. All right, so Cortex XDR does not always, it hasn't done a backup of all of your agents' registries, yeah? But certainly by analyzing the operating system interactions with different processes, we can see when registry changes are happening, yeah? But we didn't back up everything first. So in that case, we had to take a manual remediation, yeah? Restore it from a backup, for example. All right, so that's the suggestions. Again, pro license capability only, like we have with remote script execution. So let me do a bit of a demo, and that way I can do the slides briefly for that section too. So for remote script execution, let's just exit the suggestions. For script execution, we do provide you from the Action Center, we have the agent script library that you can use to run Python scripts on your agents. Some scripts are not compatible for every platform. It depends on the way you created the script or Palo Alto Networks. Yeah, they're not all created by users. If you have a brand new tenant, we'll only find out-of-the-box scripts. So I'm going to do a filter and just show rows created by Palo Alto Networks. And here are many out-of-the-box scripts. And we can provide updates to Cortex XDR. As you can see, we have different times on these scripts, different modification timestamps. So here is a script name, it's a description of what the script would do, process kill name, and then we specify the process to kill by name, and created by Palo Alto Networks. If you ever wanted to run any script, one created by you or by Palo Alto Networks, you take the script. Let me show you across more details. What compatible platforms, yeah? When you upload or create a script, you get to choose Windows, Linux, Mac OS, or just one. Yeah. So if you do want to run a script, yeah, you right-click the script and run it. If you're not sure what the script does and you want to see it, you can view the script content. Yeah, so I can then see down here. Actually, this is more the script definition. If you want to see the script content, tell you the truth, you know, if you were concerned by this script from Palo Alto Networks, you'd first of all have to download it. Yeah, that will download it to my workstation. So I can download it. I can make changes to it if I wanted to, and then upload my own custom script as well. Yeah, so I can go and check it before I decide to do anything with it. Yeah, you can't modify the built-in out-of-the-box scripts, but you can save as new, so you can then make the changes you want. Now we have a script they're going to ask you to upload, a custom Python script. I have a copy of it on my home laptop, so I don't need to go through logging into my VM for this demonstration. It's a very simple script. It's a ping2 Python script. And what it's going to do is going to ping with a count an IP. We're going to ping an IP address a number of times. Very simple script. Yeah. So if I want to create a new Python script and upload to Cortex XDR, new script, go through the upload script steps to browse or drag and drop. So I'm going to drag and drop, easier for me. And then it takes you straight away down to definitions, where we define under general the script name, but it's given us a default. I'll follow the class convention. You can choose whether to mark the script as high risk. And if doing so, if you mark the script as high risk, it requires root privileges or administrator privileges to run on the endpoint. You can again choose which will be the supported platforms. And then for the script execution, what will be the default timeout for the script to complete execution? My script actually requires that we provide input, the count, and the IP address. So I can't just run my script with no interaction by the user. I need to run my script by entry point. Some scripts might just be automatic scripts to perform remove of an old EDR because we've just installed Cortex XDR. Yeah, I don't need to provide input, for example. But my script in particular, we have to provide input. Yeah, we have to provide a value for what we're going to ping, and ping, we're going to ping again a count, which is going to be a number. Yeah, how many pings do we want? And an IP address, which will be a string. So in our case, we have to run by entry point. And then for the output, how are we going to format the output of the script results? And you can manually format if you need to, but the recommendation is to try auto detect first. And if you need to customize it, then come and customize. So it's pretty much as simple as that, yeah? So I'll create, upload my custom script. I won't see it there based on my filter. So get rid of that filter. And at the top, we see my Python script. Yeah? So if I want to run it, let me show you a couple of ways of running it. Right-click, and I can then run straight here from the script library. Yeah, and it just basically takes me to the Action Center. And the default action being run the endpoint script. It selected my script name and then prompting me, what IP address, how many do you want? What do you want to use for the timeout, the default or something else? And then you target it because it's an action in the Action Center. Yeah, like normal actions, you target it to a single, let's do it. Yeah, what do you want to ping? Again, something simple like Google. How many times, how many pings? I want 8 of them. and script timeout, and then we'll target it to 1 or 2 endpoints. We'll keep it simple. If the endpoint name contains 671, I don't need to select all of them, but I'll at least include mine, yeah, and 2 others, yeah. So that's our target step. And then next, observe the summary, and then you have these choices. Would you like to run it in the background and then see the result in the Action Center? Or do you want an interactive run so we can observe the script results and look at the output right now? Or do you want to go back or cancel? Well, let's do an interactive, yeah? And here's what an interactive run looks like. So we've now can see it's we've actually in progress for 3. 0 failed, 0 completed. Here's our Python script name, still running. It looks like 3 completed already, yeah? And the scope. And the idea of interactive mode, I'll show you the output in other ways of looking at the output. But the idea of interactive mode is I can now choose to run another script on the same endpoints because I'm in interactive mode. Or I could provide a code snippet, a Java code snippet, to then run on these selected 3 endpoints. And here's the way we're showing you the output, return value column breakdown. All 3 that completed successfully, they pinged 8.8.8 8 times with 0% loss. Maybe I want to save that out. You can as well, or change the format of the results table. And now I can see from the perspective of each of my endpoints, yeah, maybe one failed 1 ping, for example, but they all completed successfully. They all had 0% packet loss. Yeah, so I can see the results of the script execution. Still, I don't like looking at my pings that way. So when we ran the script, we generated some standard output on the endpoint. And you can view the standard output. Okay, that looks normal now, right? We pinged 8.8 8 times, 0% loss. And again, because we're in interactive mode, I can choose to run another script if I want to. I'm running the same script again. But you can run another script. Here we go. Choose the other script, yeah. And then continue, or code snippet. So that's our interactive mode. Jump out of interactive mode. Another way we can run a script, if you go to the endpoint list, I won't do this. If you find an endpoint control, is it security operations? There is an option here. You know what you need to do? You need to open it in interactive mode. That's the problem. So if I take a single endpoint or 2 endpoints, and I then endpoint control, I can open them in interactive mode. And the reason why I'll open them in interactive mode, the same as what we just saw, is so I can choose which scripts to run on those targeted endpoints. So instead of using the script library, yeah, to start the process, you can do it straight from the endpoint list. Yeah, any questions, you're welcome, of course. So, and in the future, if someone else needs to then see what the script results are, of course, we have the Action Center. Yeah, so we can see this action that I just, yeah, completed successfully, 3 completed successfully. So maybe someone else needs to analyze the script results so they can go back into the Action Center later, right-click, additional data. We bring up the Action Center detailed results like we're familiar with. We see the action was endpoint script execution, the script name. Do you want to download it if you want? Creation time, the action parameters that were used. And then we see the script results. Because I'm too big here, we're not really seeing them properly. That's better. And we're showing it to in graphical format with a, widget and the graphical results. Show it to me in details. And then we can see the detailed script results for all 3 of the endpoints. Now I'd like to see the standard output from 6715. So you can always go back and have a look at the script results as well. Or from the Action Center, it is the Action Center. I could right-click there and say, let's rerun it if you wanted to. So very simple interface. All right, so now I can catch up on some slides for that. We talked about remote script execution. We have in the agent script library in your Action Center, lots of scripts provided by Palo Alto Networks, ready to use Python scripts. If you want to upload your own script, we have the new script button. If you want to download any of the scripts, including Palo Alto Networks, you can download, save it as a Python script locally. This is a custom script, not by Palo Alto Networks. So this one I can edit. Yeah. Clone, save as new. We don't call it clone. And delete. So normal kind of management right-click options. And the process to upload a new script, you first of all browse or drag and drop for the Python script. That will then take you to the general definition section and give you a default script name. You choose your supported platforms. The default timeout is 600. And again, for the input, the default selection is just run, how you want the script to run on the endpoints. Do you need to provide any parameters or just run as is? Just run as is or provide parameters, run by entry point. So in this case, we're choosing ping, and then for IP, it'll be a string, and for count, it'll be a number. And we choose our output definition. So here's a bit of our source code, how it corresponds to the input definitions, ping and IP. The IP value has to be a string. So we can provide that when we do the run of the script from the Action Center. And the count you saw as well in my script, we have a newer script. This is an old slide from 3.0 class. Our new script also includes count. So you can choose how many pings you want to send. And then again, the output type, the recommendation would be to auto detect. Otherwise, you can change it. So there's the 3 steps. How would you run the script? If you want to use the Action Center, or you right click on the script, it will automatically choose run a Python script and the script for you as the choose step. You then have to input the input parameters. In step 2, we then target it using whatever criteria you want to match on a single or multiple endpoints. It will only show you by default the ones eligible for running the script based on the platform. If it's a Windows-only script, you're not going to see Mac OS and Linux as possible endpoints. And then again, in the 3rd step, they didn't show us the 3rd step. The 3rd step is the summary. And then you get the choice of running it interactively or running in the background or cancel. Here we then have the action from the Action Center. It is an endpoint script execution that completed successfully. I want to retrieve the data. So right-click, additional data. As I showed you, brings up the Action Center detailed results. Any action that you do in the Action Center, we right-click additional data to see what is it. Endpoint file retrieval, support file retrieval, endpoint script execution, and the details. And this is an interesting one because this action is still in progress. 1 pending and 2 completed successfully. Information about the targets. And so we would see the 3 different endpoint names in the table, like I showed you. 0, win.1, number 10, number 20. We'll see 3 of them. And we'd then be able to right-click on the ones that completed successfully, 2 of them completed successfully, and look at the standard output. Look at the results. And the other way I showed you, you can run a script from the all endpoints page. You can select a single endpoint or multiple endpoints, and then right-click, endpoint control, open in interactive mode. And that's what I demonstrated, with the mode that looks like this, where after the script execution, you then can run another script or even a code snippet on the same selected endpoints. So the benefit of running in interactive mode, your script, in comparison to using the Action Center, is you're able to run multiple scripts on the same set of selected endpoints. You can track the progress of their executions in real time, as well as the return values in real time. So right-click, endpoint control, open in interactive mode. That's again what the interactive mode looks like. We selected 2 endpoints, or when we use the Action Center and we chose the option to run interactive, this will do the same thing as you saw, yeah? We just chose 2 endpoints with the script to run, the input parameters, run it, observe the progress, and the option to run another script or a code snippet. Right. And the very last part is Cortex XDR provides 2 different URLs. We provide under settings configurations. If it's a brand new tenant, we need to go and enable the EDL service. So we have under integrations, this is the settings configurations of our tenants. And then under integrations, we have external dynamic list integration. We provide 2 different URLs that you can provide, and this is tenant specific, edl-cortex1.xdr.us.paloaltonetworks.com, block list type equals IP, and another one over HTTPS, where the block list type equals domain. Yeah. So these are, you don't get to choose these. This is based on our tenant URL. We just create for you these 2 EDLs automatically. They get registered in DNS as well. So your firewall can resolve them using their DNS. And we provide these URLs to your firewall admin. I've copied it. I can send it to my firewall admin, and they will then create an external dynamic list object, which they can use to say, let's read this list. Which list? Let's read this list that's in Cortex XDR. Let me go back to my Action Center. Let's read this list, which we show you the URLs here as well, from Cortex XDR, so that when my firewall retrieves this list of bad IP addresses, it knows dynamically, block all outbound access to them, block all inbound access from them. Yeah, that's the idea. These are bad IP addresses. Someone added Google, me, it was. I'm going to remove that, delete that from the EDL to make sure my firewall doesn't block access to Google. So here I can manage the entries on the EDL. It's not how I'm adding to them, it's how I'm removing them. Yeah. Again, a different URL for the domain name. Domain name, think www.badsite.com. Yeah. So logically, what is an EDL? Why would we use it? Again, you'll have to excuse my mouse. But if here is Cortex, where is my mouse? Somewhere on the slide here. There it is. So here is where Cortex XDR is in the cloud. And then my organization, this is my XDR instance. My organization is, of course, using Palo Alto Networks firewalls. Here's a Palo Alto Networks next generation firewall in my data center that's protecting access to all of the services and servers in my data center. I have another firewall for each of my branch offices, yeah, protecting the users in those branch offices, yeah, and providing internet access as well. Other firewalls in other parts of our network. And as soon as I, as the administrator, I'm over here as the admin of Cortex XDR, and I add a bad IP address into that IP address list, yeah? And then my firewalls will, every 5 minutes, retrieve that URL, and they have a policy that says, block access to those bad IP addresses, block access from those bad IP addresses. It's a very common thing to use with Palo Alto Networks firewalls. I'm sure many of you know about EDLs, yeah? In fact, Palo Alto Networks, by the way, if you do use EDLs on your firewalls, like I'm sure you do, Palo Alto Networks actually provide, many people don't know, but Palo Alto Networks provides an EDL service, an EDL hosting service, so that if you want your firewalls to get a list of Azure IP addresses or GCP addresses in different regions, yeah, we have a hosting service. We provide lists of IP addresses for, let's say, AWS. AWS where? Where do you want? So we'll choose, where are we in Singapore? Asia Pacific South, yeah? And then here we have the different URLs I can provide to my firewalls, so my firewall can allow access to this part of AWS or Azure or GCP, Okta or whatever. So we provide it's just a list of IP addresses, yeah? / with a mask as well. supported. So Palo Alto provide EDLs for, to allow their customers to secure and restrict access to certain authorized cloud services, yeah? A EDL hosting service. If you want me to send you information on that, I'll share the URL. Otherwise, I'll keep on going. But this is an EDL in Cortex XDR. So I get to choose which bad IPs, which bad domain names do I want to add into this, because they're bad. Yeah, they're bad ones. I want to make sure my firewalls will prevent access to or from them. So how would I do that? Yeah. How would I do that quickly? I won't keep you too long, don't worry. My quick launcher, a bad IP address I've just found doing some causality analysis of an alert, 87.54.32.21. I'm using quick launcher. Yeah. Press enter. Quick launcher. It's trying to search about information about, do I want to search for network connections to it from the log data we've received from my pro agents, or the logs from my firewalls? Do I want to search for network connections from it? I've already determined this is a bad IP address. I'm making it up, right? So I'm going to add it to my EDL. You sure you want to do that? Yeah. All right, great. Another one. Do something else. www.reallybad, yeah, .com. It's a domain. I'm going to add it to my EDL. You're about to add it to your EDL. Of course, those actions are tracked in the Action Center. So we go back to I always lose the right tab, but anyway, we go back to the Action Center where we can manage the entries in the EDLs, and we'll find those. That's just added there, and that's just added there too. Yeah. Okay. So briefly, you know how I do things. I'll give you a demo, then I can do some slides briefly. Yeah. You can always ask questions if you want me to slow down. An EDL, external dynamic list, is a kind of a block list, but it does nothing unless you configure your firewalls to retrieve it. Yeah. So Cortex XDR instance can serve two different lists over HTTPS, as you've seen, IP addresses and domain names. And the consumer of our EDL service is something like our next generation firewall running PAN-OS, or it could be Prisma Access, a firewall in the cloud that the customer provisions, yeah, in the Prisma Access cloud. It's something that can ingest our EDLs. So, it doesn't cost anything extra. You bought the pro license. One time you have to go into our settings, configurations, integration. You have to enable the EDL service. It's disabled. There's a slide button. And you have to configure the username and password for authentication. That's a one-time job. Takes about 30 seconds. And then ongoing, how different methods of adding a host or IP address to the EDL. You can do it from the Action Center. You can do it from the response options. From Quick Launcher I showed you. From the IP view we'll learn about tomorrow. Whenever it shows you an option to add to the EDL, that's what it means. And we then manage the entries on the EDL from the Action Center. All right, so here's our one-time job under Settings, Configurations, Integrations, External Dynamic List. This is what's turned off by default. We have the URLs for you automatically. They're already registered in DNS. Yeah, but you need to slide this on after you configure the username and password. For more information, come and attend the EDU 210 class, the Firewall Essentials class. It would be great to see you again if you haven't sat it. Come and learn about the world's best and first next generation firewall. Yeah, Palo Alto Networks. Or check your admin guides. Yeah, I'll keep it short. Here's one of the response options we were provided. Yeah, Action Center, Live Terminal, or add it to the EDL. You can use the Action Center, choose that as the action, add something to the EDL. It will auto-detect if you type in an IP or a domain name. You can add multiple, go through the wizard process. Here we have through Quick Launcher. This is an interesting one. If the IP address is one of our XDR agents, the option will be grayed. will not allow you to add it to the EDL if it's one of our agents. And here we've done we're using the IP view. We'll learn about it tomorrow. We've identified this to be an external French IP address, I think, and some analytics about it as well, but we do have the option. No, we don't. It's already in the EDL, but normally there's an option to add this IP to the EDL unless it's already there. If I had to remove this IP from the EDL, they can't get to my French, cooking site or something like that anymore. Then we go into the EDL option in the Action Center, and you can delete them from here. You can't add them from here. Oh, I told you, short and sweet modules. The work is for you to do the labs, to learn about our product, our wonderful product. So hopefully now you have confidence to use the different ways of performing remediation suggestions on a process node, or for the whole alert, or for a whole incident. You know how to upload a custom Python script, different methods of running it, and using the Action Center to track the status, look at the results afterwards. You know the one-step job required to activate the EDL and then to add and remove entries. So you can now manage those lists of bad IP addresses and domain names. So perfect. I've left you half an hour for more lab time. If you do need to leave, that's fine. However, your mission is before tomorrow morning. You want all labs up to the end of activity 4.1. It's only a 2-day class, right? You don't want to get too behind. We also have labs to perform tomorrow. So it's a very short lab, this one. I do demonstrate a lot of what you do in the labs, but that doesn't mean I don't want you to do it, right? So lab time, if you still want to stay with me, if it's late for you, you need to go home before peak hour, traffic, or be with a family. Once again, please complete to the end of activity 4.1 before 9 a.m. tomorrow morning, and we're all perfect. Any questions, call out. Otherwise, I'll be quiet for you. I hope you've enjoyed day one of EDU 262, the analysis and response class. It's a bit more fun. Yeah. All right. So I'll leave you to it. Call out if you have a question. Don't feel bad if you want to say goodbye in the chat or call out and you need to drop off. That's okay too. It's almost that time of day. So I'll leave a note. Yeah. I'll stop talking in case someone does want to talk. Thank you, Thomas. Great. My pleasure. Thank you very much. Appreciate that. I'm trying. No one falls asleep in my class, right? I don't let them fall asleep. So please complete all labs until end of lab 4.1 by 9 a.m. tomorrow. And that's great. If you want to leave, that's fine. Yeah, I get it. I would too. All right. Thanks so much, everyone. Thank you, Sean. Very good. No one does. And I'm trying to make sure I'm giving plenty of time for the labs as well. I hope you've noticed. Yeah. That's the important thing, to really come to learn how to use the product. Thank you very much, Philip. Okay, see you.